Hello everyone, and welcome to your video on exponential growth. So first I'm going to show you a chart of regular growth. So here we have, this is how many cookies you eat if every hour you run over and you get 2 more Oreos out of the Oreo container. So your first hour you had 2, your second hour you ate 2 more, so now you've had 4, your third hour you ate 2 more, so now you've had 6, and then that just continues, and you see you get this nice straight little line here, which is just lovely and easy to understand. Not all things, however, can be represented by such a nice straight line. For instance, let's take a look at exponential growth. Exponential growth in this example is from, you start with 2 cells in a petri dish, 2 bacterial cells of some sort, and every hour you double the number of bacterial cells that you get. So at first, this looks, nice and flat and even. So you would have 2 cells at 1 hour. You would have, or you would start with 2 cells maybe, and then you would have 4 at 1 hour, and you would have 8 cells at 2 hours, and it would double again, so you would have 16 cells at 3 hours, and then that would double again, and you would have 32 cells at 4 hours, and then 64, and then 128, and 128 times 2 is 256, and 256 times 2 is 512, and 512 times 2 is 1024, and 1024, okay, so you get the point, okay? Notice how it looks like it's kind of slow growth here, but then it really starts to get crazy. The reason that this is called exponential growth is because the amount of growth can be expressed with an exponent. So for instance, we started with 2 to the 1 cells, and then we went to 2 to the 2, which is 4, and then 2 to the 3rd, which is 8, and 2 to the 4th, which is 16, and 2 to the 5th, which is, do you see what we're doing here? So this is, the exponents are changing. So this is a 2. The exponents are changing, so we say that this is exponential growth. If you put the 2 graphs on one page together, you really start to see a difference. Here's the cookies in the nice straight line that you ate. Remember, you ate 2 every hour. And here are the cells in the petri dish, which double every hour. The cookies is a nice straight line, but exponential growth will always give you this curve here. And that's one of the ways that you know that it's exponential growth. It is not correct to say that something grows exponentially just because it grows fast, okay? Fast growth is fast growth, but exponential growth means that the amount of growth you get is dependent on how much was there before it grew. So we started with 2, so that's why we have 4, and that's why we have 8, and that's why we have 16. The number of cookies that you eat is just always 2. It doesn't matter how many you've already eaten before. It's just always 2. Okay, so what things grow exponentially? Well, exponential growth is often used to explain things like population size. So here we had the growth of our cells in a petri dish, but this could also be the number of rabbits living underneath your back porch. It could be the number of wolves in Yellowstone Park. It could be any of those. Any type of population tends to have some sort of exponential growth factor to it. Another thing that grows exponentially is the weight of a baby. babies start out quite small, and then they double their weight in just a few months, and then they will double their weight again after that. So the weight of a baby can be said to be exponential. Another thing that grows exponentially is energy usage. So for instance, imagine back in the times when coal first came online, and we went from using almost no coal to using a little bit of coal, and then we doubled that, and then we doubled that, and then we doubled that. Or maybe we didn't exactly double it, maybe we tripled it and tripled it and tripled it. Or maybe we 2.4'd it and 2.4'd it and 2.4'd it. But it went up according to this curve, okay? The amount of coal that gets used. The other thing that grows exponentially is your debt, right? You start out owing no one anything, and then you borrow your first $100, and you start paying interest on that $100. So the amount that you've borrowed influences the amount that you have to pay in the future. If you borrow $100, you're going to have to pay more than if you only borrowed $80. If you borrow $80, you're going to have to pay more than if you only borrowed $40. Okay, so these things have exponential growth. The point that I want to make here is that exponential growth is limited. In other words, it doesn't go on forever. It stops. At some point, it stops. And I say this because lots of times you will hear in our news that, oh, such and such is going to experience exponential growth. Well, great, but you and I need to be aware of the fact that that growth period, that period of exponential growth, will not last forever. For instance, if you were looking at cells in a petri dish, eventually some of your cells will start to die too, right? And so your population is going to level out. At first, everything is living, but then it goes like that. So you get more of an S shape. Same thing as the weight of a baby. Baby's putting on, and then they also start running around, and they start eating different foods, and they start, not gaining weight as fast. Energy usage. You take coal as an example. We started with this great exponential growth, and now you see it leveling off. Why? Well, maybe we run out of coal, or maybe it's because we switch over to solar power, or maybe it's because we are no longer having all new businesses coming online with it, right? That most things are already hooked up to regular electrical usage. But in any event, you see this slowing over time. Same with your debt. Yes, it goes up, it's exponential, but at some point, your debt starts rising. Often, that is because you die. But the point is that it stops rising. Now, when you take a look at something like the government, their debt can go up a lot longer because they're going to, live, if you will, for a lot longer. So notice that you get this nice S shape. And that is showing you that this is the period of exponential growth, and then this is the leveling out. I just think that it's important that you understand kind of what those terms are, because they get bandied about a lot. So there you go. Regular versus exponential growth.